All right, today we're going to talk about scatter plots. Uh, Scatter plots and bivariate data. I can create and interpret scatter plots as your learning goal for today. So scatter plots is all about making connections between two different things. So if we looked at these examples, I went through these with the in-person class and they had to match them up. So like the more it rains, and then which of these would match with that? So the more it rains, the less people go on picnics. So we're comparing two things to make connections. So what about the warmer it is? What would that be? The warmer it is, what do you think? The more people play outside. The more you read, the more intelligent you are. The longer you sleep, the less tired you are. So scatter plots is going to be about making connections between two different things. So first off, we'll go through and based off of our pre-test results, instead of stretching this out, I'm kind of going to go over everything just on these one notes. And we should be able to get through scatter plots pretty quickly because our results were pretty good. So what is a scatter plot? Scatter plots are used to compare two sets of data, which are two different variables. Two sets of data are known as bivariate data. So so that's two, variate variable, two variable data. So we're comparing two things, your x and your y. All right. They can be used to look for a connection between the two sets of data. This connection is called and there's four different ways you'll hear it. They kind of change in each grade. They could say, look at the graph and tell me what's the correlation, or they could say, what's the relationship, or what's the trend, or what's the association. All four of those things mean the exact same thing. So if they look at it and they ask you for one of those, they mean the same exact thing. So like, what's the relationship in the graph? What's the relationship between X and Y? What's the trend between X and Y? So just know once we go over what that means, that all four of those are the same thing. So if we look at this scatter plot, what are the two variables being compared? So if you look at this graph, what are the two things we're comparing? We're comparing height on the x-axis, and we're comparing weight on the y-axis. So it's important to know the difference between the independent and dependent variable. The independent variable does not depend on another variable. It happens on its own, right? So it's not affected at all by the other one. The dependent variable does, which is, so it does depend on the other one. So if we look at this graph, does your height, can your height be affected by your weight? Does your height depend on your weight, or can your weight be affected by your height? Which one's independent? Which one's dependent? So the independent variable is your height. And independent is almost always going to be on the x-axis. So your independent variable is your height. Your dependent variable is your weight. So your weight can be affected by your height, but your height cannot be affected by your weight. Is there a relationship between the height and the weight of an object according to the data plotted in this scatter plot? So if you look at this graph, does it look like there's a relationship between as the height increases, so as somebody is taller, the taller they are, does that affect the weight by looking at the graph? And with the kids in class, I had them look at it. They gave me some ideas, tell me what they thought, and then that was it. We moved on. I didn't tell them what it should be. So this is just you looking at this and thinking about, what do you think? Do you think there is a relationship between weight and height? All right, so making a scatter plot. So if we get a group of bivariate data, so if we get two different variables, we've got height and weight. So we have somebody here who's 71 inches tall, they weigh 170 pounds. Somebody who's 68 inches tall, they weigh 160 pounds. So we have a set of data and we want to put it in a scatter plot. So all you do is first list out all your points. So these are our points. We have the point 71, 170. We have the point 68, 160. 70, 175, and so on. So then we put it in a graph. Now, I went over this with the class in person. If you look on our X and Y axis, we're not starting at 0 and counting by something. They start at 0 and they skip. They take a big jump. So we went 0 and then jumped all the way to 68. All right. That's called a break. So it's like a break. It's called a break. So it's a break in the table that lets you do a big skip. All right. So when you're doing scatter plots, if you're not going to start at 0 and count, if you're going to jump to a bigger number and then count, you have to put a break in the graph. So if we look, our lowest number is 68. Our biggest number was 74. So they went, okay, 0, break, jumped all the way to 68, and then 68 counted by 1s to 74. For the y-axis, it's always important to figure out what you're going to count by. They started at 160. The biggest number is 190. So they decided to go 0, break. They started at 140 and counted by 10s up to 200. And then you plot your points on the graph. So that's kind of the basics for making a scatter plot, which most of you should already know. This should be a review for a lot of you. So if we look at this graph, we have our table. We want to put it in the scatter plot. We have our X and our Y, what they wanted to count by. Since they did a big jump, you would put a break in it right there. So then plot the points. 60. Oh, good morning. All right. That student came in to get their Chromebook, didn't even say good morning back. So disappointing. All right, so 63 over 63 up 125. Then we have our next point, 67, 156. So over 67 up to 156. 69, 175. So we go over the 69 up to 175 and so on. So you just plot your points on the graph. So that's the basics of making a scatter plot. So this should all start to look familiar to you. So we've got our points, we put them on there. So now let's take a look. We have this scatter plot for children's heights. Their age in years, from 5 years old to 14 years old. Their height from 0 centimeters to 180. And then we've got some questions. So you should be able to look at the scatter plot and answer these questions. So I want you to go ahead and pause the video. And I want you to look at these questions. And you don't need to write them down. I just want you to look at them and answer the questions. What do you think? So pause the video and do that. All right, so in the above chart, who is the tallest? What did you put? So the tallest student, if we look at height as you go up, so the point highest on the graph is Phil. So Phil should be the tallest. Who appears to be the youngest? So then age goes from 5 to 14. So the farther right you go, the older they are. So to the left, who is the youngest? You should have said Ben and Ann are the two youngest. They're both 6. How much taller is Eric than Ann? So if you looked at that, you would have said, okay, here's Eric. Eric is 160 centimeters. Ann is 120. So 160 minus 120. Eric is 40 centimeters taller than Ann. How much younger is Nash than Jen? All right, so if you go to Nash, Nash is 8. And then Jen is 13. So how much younger is Nash than Jen? 13 minus 8. Nash is 5 years younger than Jen. And then here's our last question. If Amina, who's not on the graph, so if Amina is 10 years old and 140 centimeters tall, how would this be shown in the graph? So if she's 10 years old, she would have a point. She'd be over at 10, and 140 centimeters, her point would be right there. So you got to be able to look at a scatter plot and answer questions like that about what's going on in the graph. Hopefully you got all of those right. And then, all right, now let's get into being able to look at it and talk about the actual relationship in the graph. So a correlation describes the type of relationship between the two data sets. So remember, we said correlation, trend, relationship, association, they're all the same thing. It's going to describe what's going on between the two variables, your X and your Y. Then you have what's called the line of best fit, which you should have talked about before. The line of best fit is the line that comes the closest to all the points on the scatter plot. This can be drawn when there is a linear association. So all that means is if I look at a graph, and there's the line, say, pretend this line's not here. You look at a graph, you see all the dots, and if it looks like, yeah, I could draw a line that would go through the middle of the dots, that means there's a linear association. That means the dots, they're not a straight line, but it means the dots are going in a pattern in kind of a close clustered line together. And then the line of best fit would be, okay, I see all the dots. I want to draw a line through the middle of them that kind of gets you as close as it can to being straight through the middle. Now, is everyone's line of best fit going to look the same? No. They could all be off just a little bit, but as long as it goes through the middle of the points, then it would be correct. One way to estimate the line of best fit is to take a ruler and you put it on the graph and adjust it until it looks closest to all the points. The closer the points cluster to the line of best fit, the stronger the relationship, the correlation, all that we're going to talk about in a minute. So the closer the dots are to the line, the stronger the relationship you have between the two things. All right, so we just take a look. Here's the kind of the 5 main types of graphs you're going to see. All right, so here's 2 that are positive. So you could have a positive relationship where you see as you look at the graph, as you go from left to right, the dots are going up, the points are going up. So if the points are going up, that means you have a positive correlation, a positive relationship. Both data sets increase together. So as the X is increasing, the Y is also increasing. Now, like I said, remember, the closer the dots to points, the closer they're clustered together, the stronger the relationship. So if they're together close in a group, that's a strong correlation. If they're kind of spread out but still going in a pattern, that's still positive, but it's a weak one. All right. Then compared to the middle graph, where does it look like the dots are going up? Does it look like they're going down? No, they're just scattered around everywhere. So that's no correlation. There's no pattern. No correlation, no relationship, no association. Remember, those are all the same thing. So there's no relationship there. And then if you look at the last one, the dots are going down. So that's a negative correlation, a negative relationship. So as the X is increasing, the Y is decreasing. Right? So as one data set increases, the other decreases. So this one, you can see the points are kind of spread out. So it's weak compared to this one. All the points are kind of clustered right around the line. So that would be a strong relationship. All right? And that's one of the things when you look at the graph, you're going to have to be able to tell, is there a positive relationship? Is there a negative relationship? Or is there no relationship? Is it strong or is it weak? You got to be able to tell the independent and dependent variable, which we've talked about. Remember, usually the independence on the X, the dependence on the Y. All right, let's skip through these. All right, so use the given information to make the scatter plot. So I've got grading period 1, 2, 3, 4, the number of A's in the class 5, 6, 8, 10. So there's our scatter plot. The next thing we're going to talk about is if they say, okay, look at the scatter plot, and they say, state the association, or state the relationship, or state the correlation. That means they want you to describe what's going on, describe the relationship between the two things. So as the grading period does what? So as you go from left to right, as the grading period increases, because you're going left to right, so as the grading period increases, the number of A's is doing what? And when you're doing this, I'm going to type this, change this, because it's always going to say that. save that. All right. So when you're doing these problems, it's always going to say increases for the first one. That's how you're going to state it. So always talk about the x, the independent variable. So as the grading period increases, because we're going left to right, as the grading period increases, the number of A's are doing what? Are the dots going up or down? They're going up. So as the number of A's, as the grading period increases, the number of A's does what? It also increases. All right, so that's how you would have to be able to look at it. If the dots were going down, you would say as the grading period increases, the number of A's decrease. So it just depends on what's going on in the graph. All right. You can also use scatter plots to predict what's going to happen at other places in the graph. For example, if I graph these, the hours and tips, so you've got somebody who worked 4 hours, made $12, 8 hours, made 20, 3 made 7, 2 made 7, 11 hours, and they made 26. They then drew the line of best fit. So then you can use the line of best fit to kind of figure out, according to the graph, a worker will earn approximately $24 in tips in 10 hours, because it said predict how much will they make in 10 hours. Well, 10 hours isn't on the graph or isn't in the table. So you go to the graph and say, okay, 10 hours, you go up, where does it hit the line? It hits the line right there. So that would be about $24. All right, so let's look at another one. Use the data to predict how many circuit board a worker can assemble in 10 hours. So you can see, okay, hours worked, 4, 8, 6, 9, 11, how many they can make. So you could look at this and say, okay, at 9 hours, they made 8, and 11 hours, they made 12. How many do you think they could make in 10 hours? Well, you plot the points. There's your line, and then you just go, okay, 10 hours, where does it hit the line? 10 hours, 10 circuit boards. All right, so almost done with our notes. Last thing we're going to talk about, outliers. An outlier for a 2-variable data set for a scatter plot shows a point that is away from the overall pattern. So if we look at the graph, we have fat in grams and then calories. There's our points, and then every once in a while, if there's a pattern, you'll see, okay, I got a pattern, but then, well, whatever food this is, it's not following the pattern, it's way over here by itself, it's an outlier. So an outlier is going to be when you have, okay, all my data looks good, it's all going in a pattern, but then there's one point way over by itself. So that's an outlier. So you're getting ready to have some questions you're going to have to answer on the next few slides, and these are the questions you're going to have to answer. So let's take a look and answer them together with this one, and then I'll have you do them for the other one. So number one, looking at that scatter plot, what is the independent variable? What is the independent variable? So if you look, we said the independent variable is usually the one that's on the x-axis, so the independent would be what? It would be fat. What's the dependent variable? That's going to be on the y-axis, so the dependent variable is calories. All right. Number two, is there a linear association? Is there a linear association? So if you look at the scatter plot, here's your dots. Is there a linear association? That just means, does it look like the dots are going in a pattern? Does it look like they're going up together, or does it look like they're going down together? If they do, then that means there's a linear association. If they're just scattered everywhere, then that means there's not one. So is there a linear association for this graph? Yeah, you can see they're going in a pattern together. So yes, there is a linear association. Is it positive or negative? So if you look at the graph, are the points going up together or down together? They're going up, which means it is a positive association. Positive, so there's a positive relationship. All right, is it strong or weak? So if we look at this, if I drew a line going through these middle of these points, are these points close to the line or are they far away from the line? They would be pretty close to it. So I would call this a strong relationship. Now, if they were going up, but you had point here and here and here and here, and they're spread out more, then it would be a weak one. But these are all pretty close to, if I drew a line, they'd be pretty close to that line. So that's a strong relationship between calories and fat. And then the most important question, state the association. Well, what is the relationship between calories and fat? Well, and then remember, you always say it the same exact way, as the, what's on the X? Fat. So as the fat increases, the calories blank. So this is the way you're always going to answer this question. You would say as the, and whatever this is, as it increases, and then you got to tell what the other one's doing. So for this question, as the fat increases, the calories is doing what? The calories, it's going up, it's positive, so the calories increase. So as the fat increases, the calories increase. So that's what the association is. Now, if the dots were going down, you would say as the fat increases, the calories decrease. All right, and this is important because your assignment is going to be to answer these questions for these next few slides on here. So that's what your next assignment's going to be. So you're going to have to make sure you watch these notes, know what's going on, and then you're going to do, it's going to be posted as an assignment on Google Classroom, and you're going to have to open a Google Doc and answer these questions for the next few slides. So you're going to make sure you know what all of these mean. Now, what happens if, when I looked at this, I named, number one, I named the independent, named the dependent. Then I got to number two, if it said, is there a linear association? What if the dots were just randomly everywhere and there was no pattern? Then you would say, is there a linear association? No. And if number two is no, then that means you don't answer 3, 4, 5. Because if there's no relationship, if there's no association, then it can't be positive or negative, it can't be strong or weak, and there can't be anything to state. So when you're doing these questions, if number two is no, then that's it. You just stop because you can't answer 3, 4, or 5. All right, so I'm going to go through each slide so that when you're doing your assignment, you can pause it, go to your Google Doc, answer the questions on there. So if we take a look, your first assignment, let's practice. Your, not first assignment, but your first question. All right, you've got height and weight of soccer players. You've got height, you've got their weight, you've got your points. So you need to open a Google Doc. You need to, and you know, these are your notes for today. Today's Tuesday. Your assignment is to watch these notes. Wednesday's assignment is what we're doing right now. So you can do this to go ahead and do it now, or you can wait till Wednesday to do it. But your Wednesday assignment is going to be to answer these questions in a Google Doc and submit them in Google Classroom. So if you want to go ahead and do it now, you can. If you want to wait and do it on Wednesday, that's fine. But here's your first problem. Problem A, height and weight. So number one, what are the independent and dependent variables? So you need to type in question A, number one, and then put the independent is what? Which one of these is the independent variable? Which one is the dependent variable? All right. And then number two, is there a linear association? Yes or no? Number three, if this is yes, then you answer these questions. Remember, if this is no, then you stop. So if it's yes, then you go to number three, is this positive or negative? Then number four, are there any outliers? So if you look at it, is there any outliers? Are there any points way off away from the other ones? And then number five, you have to state the association. State the association. Remember, that always is the same thing. You would type, as the height increases, the weight blank. And you have, that's the thing you have to figure out. What goes in that blank? What's going on? So as the height's increasing, the weight is blank. What's the weight doing? All right, so there's your first one. You can pause it, answer these 5 questions, put it in the Google Doc, question A. All right, if you finish that, Here's your next one. Question B, wait time in movies. So you've got time waiting in line, and you've got movie attendance. Here's your points. Answer those same 5 questions. Hide that so you can see. So answer those same 5 questions. So type B, 1, 2, 3, 4, 5. Answer those same 5 questions. All right. So if you've done that, if you pause the video, if you answered those, then I'll take you over to our next question. So our next scatter plot, we have student grades in homeroom. So here's the student's grade, their grade in math compared to their grade in art. And there's your points. So then this is question C. 1, 2, 3, 4, 5. Answer those questions. Type them in there. All right. If you've done that, then we can go to our next slide. Question D. Question D, we have scatter plot of weight versus height. So we have height and weight. Here's our points. Answer 1 through 5. All right, if you've done that, we'll go on to the next one. It says D, but this would be question E. Temperature in Fahrenheit and Celsius. So degrees in Fahrenheit compared to degrees in Celsius. So there's your X and your Y. You've got your points. Answer 1 through 5. All right. This would be F, even though it says E. Remember, this is F. So height of a ball tossed into air. So if you throw a ball in the air, as time goes on, what happens to how high the ball is up in the air? So answer these 5 questions. And this is question F. All right, moving on to our next one. Question G, you have car length and miles per gallon. So you have the length. So the longer the car is, the miles per gallon does what? So as the length increases, the miles per gallon does what? What's happening in the graph? So answer 1, 2, 3, 4, 5. 4. We said this was, I don't remember what letter it was, but you should have it. You should be keeping track of that. We're almost done. All right. So you've got that. Make sure you've answered them. And then, all right. So that's it. So that's all your questions. That next one, all those IXLs, you're not going to have to do those. Those are for the in-person class, so don't worry about those. So Tuesday's assignment, which is when I'm recording this, is for you to watch this video. And then Wednesday's assignment is for you to answer these questions. So make sure that you have done that so that you can get that turned in. All right. If you have any questions, email me, come to a Google Meet, let me know.